Here are solutions to homework set number 6 for ECE 111, Introduction to ECE. This homework set looks at differentiation, problems you run into when you take Math 165, Calculus 1, how to solve those problems using Matlab and numerical techniques. Now the first problem is just kind of the concept question. What is differentiation? The derivative of a function is the slope. So like here, if I am walking, and this is time in seconds, if I'm not moving, my velocity is 0. If I'm moving south, I am moving 3 meters in 2 seconds. So this would be moving south at a speed of 3 meters every 2 seconds, so minus 1.5. So the derivative is 0, drops down to minus 1.5. Now I'm stationary. My velocity goes back to 0. Now the velocity is changed in y, dy dt. So dy is plus 7. dt is plus 2. The derivative is 7 halves, or 3.5. So the derivative jumps up to plus 3.5. I'm now stationary. The velocity drops down to 0. Now it's minus 7 over 1. Minus 7 plus 3 in 1 second. Moves at 3 meters per second. Then back to 0. So this is the derivative. Again, derivative is just slope. So that's what it should look like. So one way to find a derivative is to sketch it by hand. A second way is to calculate it. You'll be doing that when you take Calculus 1. A third way is using Matlab and numerical techniques. So here's a function. Find the derivative. If you've had Calculus 1, you might be able to find that derivative. If you haven't had Calculus 1, that's the beauty of Matlab. I can find the derivative using numerical techniques. And the idea is if I have a function like this, the derivative at any point is the slope. So take the point after and the point before. Take the change in y over change in x. The ratio is dy dx, or the slope, at this point. So here I'm going to create a function in Matlab called derivative. It's a function. I pass it two vectors, x and y. At each point, I then calculate what's the change in y over change in x, and store that as I spin through the array. So here, since I'm taking the point after and the point before, I can't start at the first point and the last point. That's why I go from 2 to n minus 1. The two endpoints typically have problems, so one way to find it at the endpoints is just take the first 2 points, take the last 2 points, find the change in y over change in x. Let's see. I hope I do that right. Yeah. Or, no, a couple ways of doing it. So with that function, I can sit there and try to find the derivative. So here's my function. X goes from minus 10 to plus 10. Here is my function, e to the minus x squared sine of x. That plots as the blue line, so this is y. The derivative then, I will calculate at each point, what's the slope at each point, and plot it. So here is dy dx. And as a check, when y is a constant, flat, the derivative is 0. Again, here y again is flat, the derivative is 0. When y is increasing, the derivative is positive. When y is decreasing, the derivative is negative. So it looks kind of reasonable. Beauty of Matlab is I don't have to know what this equation is. If I can get y into Matlab, I can get the derivative. When you take calculus, I'll find the equation for this line. Matlab doesn't tell you the equation, but whatever the equation is, that's what it looks like. Problem 2. If I have 2 sine waves, find the derivative. And again, in Matlab, I don't really care. As long as I can get the function into Matlab, derivative will find the derivative of it. So input the function y, that's the blue line. The derivative is then the red line. And kind of note, when I differentiate, the high frequency terms get amplified. Problem 4 looks at path planning. Suppose I want to go from 0 to 1 in 5 seconds. A couple ways to do that. One approach is to come up with just a straight line. If I do that for a motor, the velocity is the first derivative, that's voltage. The acceleration, second derivative, is basically current. So if I do that, first put the function in Matlab. Here I offset it by 10 to the minus 6 because I don't want to mess around with greater than or equal to, that kind of mess. So it's never going to be equal to. That's what this offset does. My function is t over 5 for t greater than 0 and t less than 5. That's this part of the curve. Then the last part is 1 for t greater than 5, and default is 0 for t less than 0. Now find the first derivative, find the second derivative, and plot them. Here's what that looks like. So here's y. Here's the derivative of y. And one type of notation is y prime. That means first derivative. Here's the second derivative. So this would be position, voltage, and current. This is probably not a good path to go from 0 to 1 because the current goes to infinity at the start and the end. Electronics don't like that. So another way to do it. Again, I want to go from 0 to 1 in 5 seconds. One way is to have a cosine function right here. So here's the cosine function. Winds up at 1. If I do that path, what is the voltage? What's the current? Well, to do that, I find the first derivative, find the second derivative. Again, nothing changes. Keep using the derivative function. So here is position, velocity, acceleration. That's a much more reasonable function. Again, the velocity goes up and down. Here's the acceleration. It doesn't have these spikes at the beginning or end. That's one path that might be valid. Third approach, I could do a cubic function. I want to go from 0 to 1 in 5 seconds. Let's do a cubic. So here's the equation for a cubic function. Kind of the way I did that is I want the position and velocity to be 0 at the beginning, position to be 1, velocity to be 0 at the end. Given 4 constraints, a third order polynomial has 4 degrees of freedom, solve for those 4. And if you do that, that's what it winds up being. Let's try it. Throw that in Matlab. So here's the equation between 1 and 5. Here's the equation after 1. Find the first derivative, find the second derivative. So again, here's y prime, y double prime. What you're seeing is when you take calculus, you'll learn the derivative of a cubic is a parabola. The derivative of a parabola is a line. If you haven't had calculus, not a problem. That's what Matlab's for. So that was homework set number 6. With Matlab, I can find the derivative of functions. What Matlab won't give you is what's the equation for this function. What it will tell you is that whatever the equation is, that's what it looks like. That's homework set number 6 for ECE 111.